This is the integral we're going to evaluate for this video. You want to give it a try? Go ahead and pause the video. I'll be right back. Okay, for this particular video, we can't use partial fractions. You got the e to the x there. U substitution doesn't appear to work here either because of that exponential. So I'm going to try integration by parts, and I use the normal procedure. I'm not going to use the abbreviated form. This was not too bad, and I'm going to break this up into two functions. One function will be x e to the x. That's the one I'm going to differentiate. So x e to the x, and the one I'm going to integrate will be the rational expression 1 over 1 plus x to the second power. So for the first one here, the derivative, I have to use the product rule. So it'll be du equal to the derivative of the right side. So say the first one takes the derivative of the first, so it's x times the derivative of e to the x will give me e to the x plus e to the x times the derivative of x is 1, so this will be e to the x. And I'll put this in parentheses. This will be dx. Now if I were to use a u substitution to evaluate this one, 1 over 1 plus x to the second, u would be 1 plus x, du would be dx. So this would be the same thing as taking the integral of 1 over x squared. I would bring it up to the numerator, get this, add 1 to the negative 2, and then divide. Well, this one, pretty much the same thing. So dv is equal to that, so v, and I rewrite this over here. I write this as 1 plus x to the negative 2, and then we have then 1 plus x, and then we add 1 to this exponent, it gives me a negative 1, and then divide the coefficient by negative 1, that'll give me a negative 1 and just a negative here, and this is what we have. And you can check this, take the derivative of this, negative 1 times negative 1 here, that's positive, subtract 1 from that, that's negative 2, and then go to the chain rule, derivative of 1 plus x is 1, that gives you the same thing back. So then we set it up over here then, integration by parts, it's a u times the v. So we have u times the v right here. So this will be x to the x times the v, this is right here. So that's going to make this a negative. And then I'll go ahead and put the, instead of 1 plus x and negative 1, the numerator I'm going to put in the denominator. The sign, the exponent goes to positive. So we get this. That's the first part of the answer. Negative x times e to the x over 1 plus x. And then it's a minus here by the formula. And then it's the integral of v du. So we have a v here, and it's got a negative there. And I'm going to rewrite that as 1 over 1 plus x. Same thing. Now I have it the other way. And then that's times the du. Okay, the du. I want to factor the x here, the e to the x here. So it'd be e to the x. Factor that out. Then I got x plus 1 dx. So the du, I should say, is just this right here. So that's part of the setup for the formula. So I have the x plus 1, you got a dx, and you got the e to the x also. And notice the x plus 1 and the x plus 1 cancel. And here I have a double negative, so that becomes a plus. Now I got left And the integrand there is e to the x dx. And we're pretty much finished here. Got minus x then, e to the x over 1 plus x. And then the integral of e to the x with respect to x is e to the x. And then you got your constant of integration. So final answer, minus x e to the x over 1 plus x plus e to the x plus the constant of integration. Now you'll work on your derivatives, compute the derivative of this expression right here, and show that it gives you this integrand here. Thanks for watching. We'll see you next time.